And that will give me and then times p prime. And to find p prime, I need to take the derivative of this function, which by itself is going to have a chain rule. So if we take the derivative of this, notice we put down the minus 1, we get minus 130, and then this is going to be 1 plus 12 e to the minus 0.02 t to the minus 2 now. And now we need to multiply by the derivative of the function inside, which is going to be minus 0.02 times 12, which is minus 0.24, and then e to the minus 0.02t. So a fairly complex product. Now, once that we have that, you can potentially simplify this, but it's kind of difficult to simplify this. So you manage to just plug in your calculator this very carefully in, and then you can plug in t equals 4, then you're gonna find out that this is approximately 0.326. Now, the meaning of this is that in 2014, the number of garbage trucks was increasing, because this is positive, by 0.326 trucks per year. Notice G is units of trucks, T is units of time, which is in year, so rate of change. Okay, so now let's move on to some examples where we find some more derivatives via chain rule. Here we have f of x is equals phi to the 3 minus the square root of x. You can see this is phi to this certain function g of x, and so in this way f prime of x will be just phi to the g of x times g prime of x. But who is g? G is 3 minus the square root of x, and so g prime is going to be 0 minus 1 over 2 square root of x. And so if we replace now this here, this is 5 to the 3 minus the square root of x times minus 1 over 2 square root of x. And that completes the chain rule in this scenario. Now for b, notice that we have 3 cosines of something. So we can see this as 3 cosines of a function h of t. And so cosine is easy to take derivative, so g prime of t is just going to be minus 3 sine of h of t. And because we took derivative, now we gotta multiply by the derivative of the function inside. But who's the function inside? Well, it's 4 log of t plus t squared. So h prime of that is going to be 4 over t plus 2t. So that means that at the end, g prime of t is minus 3 sine of 4 log of t plus t squared times 4 over t plus 2t. Now C has a sum of 2 functions. This one is easy, so I don't worry too much about that one. The derivative of x is just 1, and then minus, and so here is where we actually had to work a little bit. This is an exponential, but you guys know that the derivative of an exponential is itself, so e to the 4 x to the minus 2. Now we gotta multiply by the derivative of the function inside, that is 4 to the x to the minus 2. 4x to the minus 2. So the derivative of that will be, I put down the minus 2, so minus 8, and then x to the minus 2 minus 1, so minus 3. And so that will be the derivative. I can simplify this a little bit. Minus and minus is plus. So this can be 1 plus 8x to the minus 3 e to the 4x to the minus 2. Okay. Now the next one is one of those where I can just put up whatever is below. So I can see this as 5x to the 3 plus 7x squared plus 1 to the minus 1. And so again, this is like I have a function f of x here to the minus 1. And so if I do y prime, then this is just minus 5 f of x to the minus 2 by the rules of the power, and I gotta multiply by f prime of x. So now this is minus 5 x cubed plus 7x squared plus 1 to the minus 2, and now multiply by f prime, but f prime is the derivative of x cubed, 3x squared, plus 14x, and plus 1, the derivative of 1 is 0, so disappearing here. Now, finally, to finish up this session, we have another application. So we have that civilian deaths due to influenza in 1918 can be modeled as the function CFT, and we have this logistic function in here. So we want to know how rapidly was the number of dead growing in September 28 of 1918. So if we want to know that, first we need to find the derivative, since this is a rate of change, so how rapidly is talking about change, so it is how quickly it's increasing or decreasing. So we need to find out what c prime of t is. Okay. Again, this is very similar to what we just did. So we can think of this as 93.7, 1 plus 5095.9 e to the minus 1.097 t, and everything to the minus 1. I'm running a little bit out of space here. Let me rewrite this more clearly. Okay, so if I make the chain rule here, this is gonna give me this. Put the minus 1 down, and I get minus 93.7, and then 1 plus 5095.96 e to the minus 1.97 t, and now this is gonna be to the minus 2, since we're taking the derivative of the power. Now, once that we're done with that, we actually take the derivative of whatever is inside. And so notice that the 1 is going to become a 0, but this exponential is going to give me down a minus 1.097 term. So doing that, I get 5095.96 times minus 1.097, and then I get the exponential here. And so now this is the derivative in here. Now what we do is we take the number of months since August 31, and we want to check September 28. Okay, so we want to check September 28. Then the number of weeks since August 31, sorry, not number of months, number of weeks will be 4. So C prime of 4, and then I plug 4 in here, and after plugging 4, I'm gonna find out that this is 1.5732, and the units of this is in thousand of deaths. And since the time is in weeks, then this is per week. Because remember, it's a rate of change. Rate of change is units of outputs over units of input. Now we want to calculate the percentage rate of change for September 28. So again, we're going to use 4 because that's the number of weeks. But percent of rate of change is really asking me to do C prime of 4 over C of 4. Okay. And so if I compute that, I already computed C prime of 4. This is 1.5732, and I divide this by C of 4, which is going to give me 1.4568, and this ratio is going to be approximately 1.0799. But take into account that this is a percentage, so this means that this is 1.07.99% per week. We're finding a percentage rate of change. Now, C is repeat the two previous part for October 26. So in October 26, now we have another month. And so we, of course, need to find out C prime of 8. And then after that, we need to find out C prime of 8 over C of 8. Okay? So it's exactly the same calculation. C prime of A, if we compute that with our calculator, this is going to give us approximately 25.31. And C prime of A is 25.331 over 52.440. So this is going to give me around 0.4830. So that's around 48.3% per week. Okay. Finally, we want to know why the percentage rate of change is higher in September than in October, even though the rate of change is lower in September. So you're comparing C prime of 8 with C prime of 4, but then you compare the average rate of change. And so what happened is that the number of deaths is closer to the ROC in September that is in October, making the percentage higher. All right, and so that's gonna be the end of part 3 of the chain rule.